Hi, this is Chris, and you're watching Learn with ORM Math Help. Today we're going to be learning some neat tips and tricks about the quadratic equation, including deriving it, using it to predict what graphs can look like, and using it to predict how many zeros there are going to be in an equation. So, let's go ahead and start this out. Let's have our abstract quadratic. Let's say ax squared, where a is a constant, plus bx, where b is a constant, a different constant, and plus c, an even different constant, and a equals 0. This is our quadratic, a quadratic right here. Now, because this is a quadratic, there has to be an x squared term. This a cannot be 0. If this a was 0, then this would either be some linear or some constant equals 0, and that's not a quadratic equation. That's not really what we're trying to figure out here. If that were true, this would be pretty easy, but of course everyone knows that solving quadratic equations is never easy. So let's go ahead and, I'm sure some of you have seen the quadratic equation, but let's assume that you haven't seen it. Let's try to figure out how to solve this quadratic right here, such that we can find some x where this is true without using that formula. One way that I know a lot of people have seen, and most people hate, but it's really a powerful tool, is completing the square. That's actually where the quadratic equation came from. I think a lot of people blindly accept the quadratic equation too much, and I think deriving this equation from completing the square is really, really helpful. So let's start out. We want to get the x squared by itself at first, and because, as I've mentioned, that a is non-zero, we can legally divide through by a. Usually this would be a little bit tough because, if that a was possibly 0, then this would just totally break our equation, but it's not. So this goes to 1, and what we have left is x squared plus b over a x plus c over a equals 0 over a, or 0, same thing. So to complete the square, we need to get all of our constants to the other side. Let's do that really quick. So that's x squared plus b over a x plus equals negative c over a. Now, to complete the square, let's go back to numbers for a second. Let's go ahead and use some kind of magenta. Let's say we had x squared plus 4x, and that equals 0. If we wanted to complete the square, what we would do, and what we've learned, is to take this number, this is our b, by the way, our b, cut it in half, and then square it, and add that number to both sides. And that's really tough for a lot of people to get at first, conceptually. It's tough, it's weird, no one likes to do it because no one really understands it until they really grasp this concept of quadratics really well. But you just gotta keep practicing it, eventually you'll get that. So 1/2 of 4 is 2, square is 4. So we add 4 to both sides, and what we have is x plus 1/2 of the squared term squared, that is x plus 2 squared equals 4. And you can do that with any number of numbers. With x squared plus 6x, take half of it, we square it, we get 9 equals 9, and that's just x plus 3, that's 1/2 of this b term squared equals 9. So as you can see, if we just take half of this term, square it, and add it to both sides, that's successfully completing the square. Now 1/2 of b over a, this can be simplified to just b over 2a. So, and then, of course, b over 2a squared is just b squared over 4a squared. That's just some terms that we'll use. I'm going to kind of skip a couple steps, and just you can kind of see, hopefully you can see what I'm doing here. I'm adding this squared term to both sides. So x squared plus b over a x plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. And as you can see, this is just, I added something to both sides, and that keeps this inequality true. So this is still a true inequality. Or, sorry, a true equality. Sorry. Now, x squared plus b over ax plus b squared over 4a squared, that's just 1/2 of this, that's b over 2a. That's x plus b over 2a squared. So this can also be written as x plus b over 2a squared equals, and I'm going to flip these two because I don't like negatives being first. That's just a pet peeve of mine. So b squared minus b squared over 4a squared minus c over a. And I can do that. It's just addition is commutative, so you can switch the order, of course. So again, remember, we're trying to find what this x value can be in order to solve this equation up here. So let's go ahead and square root both sides, so we can just have a linear x term. That's nice. Back up a little bit. I always forget this step. Let's combine these two, which means we need to get a common denominator and then subtract. Now, to get a common denominator between these two terms, of course, 4a squared is your common denominator. So you can multiply by 4a over 4a. And a lot of people get really confused when we're finding common denominators and subtracting fractions against, for example, multiplying fractions or taking reciprocals or things like that. And I think it's because a lot of people aren't really exposed to the correct way to do fractions at a good age. You kind of learn fractions in 5th grade, 6th, 7th grades. Sometimes you learn a lot more up in algebra, up in 8th or 9th grade. But a lot of teachers don't really know a good way to teach everyone fractions because everyone learns, kind of visualizes it differently. But just to, and I'll have a full video on neat tricks you can do with fractions, such as what I'm doing here. And I'll have a link down here when that's up and active. But what I'm doing here is I'm just multiplying this fraction by 1. And I can multiply any part of this equation by 1, because 4a over 4a is just 1, right? And it doesn't change anything. This equality stays the same, because I'm just multiplying by 1. So, multiplying this out, I have that x plus b over 2a squared equals, I'm going to go ahead and multiply this out and subtract, because I mean, this is simple right here. B squared minus, I'm going to take this 4 over here just to make it look more like the quadratic formula that we all know and love. 4ac, you see what I did there? 4ac, it's just multiplication is commutative as well. And that's over 4a squared. Dragging this up, okay. So, now, as I was saying before, we want to find this x term by itself, just equaling some function of constants. So let's take the square root. So we just have a linear x term. So we can have, when we take the square root of both sides, this square goes away. We have x plus b over 2a, and then of course taking the square root of a rational function like this, taking the square root of this whole thing is the exact same as taking the square root of the top and then over the square root of the bottom. Remembering that, of course, the square root of 4a squared, that's just 2a. That's, square root of 4 is 2, square root of a squared is a. So, this is equal to plus or minus. Remember that you should take plus or minus when you're just taking square roots of functions, because the negative square root squared is the exact same as your positive square root squared. So you gotta make sure you have both those possibilities covered. Square root of b squared minus 4ac over 2a. And I think a lot of you probably get where this is going, but if you subtract this b over 2a from both sides and then combine and then subtract these fractions correctly where you see the same denominator, you can do that pretty easily, you end up with the quadratic equation, which is negative b plus or minus the square root of 4, oops, my bad, b squared minus 4ac all over 2a. Now, a lot of people know this formula. A lot of people use it to find solutions of quadratic equations, and that's good. It's a good thing to use it for. But a lot of people don't understand it graphically, what they're actually finding when they're solving quadratics.